بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Math grade 8. We are in model 5, lesson 5. Today we have nonlinear functions. Nonlinear functions. In this lesson, we want to determine in a function represented in different forms is a linear or non-linear function by using the rate of change, shape of the graph or structure of the equation. The first idea here in this lesson, identify linear and nonlinear functions from graphs. Linear functions have graphs that are straight lines because the rate of change between any two data points is constant. Nonlinear functions are functions whose rates of change are not constant, and therefore their graphs are not straight lines. For example, in the first graph, as you see here, we have linear because here we have straight line. When you have in the graph straight line, means you have linear. In the second graph, as you see here, we have curve. We don't have straight line, so this is non-linear. For example, identify linear and non-linear functions from graphs. Determine whether the graph represents a linear or non-linear function. Explain. As you see in this graph, we have this part, then in the origin we have this part. So this is not straight line. So this is not linear. So is the graph a straight line with a constant rate of change? No. So the function is non-linear because the graph is not a straight line. Determine whether the graph represents a linear or non-linear function. Explain. As you see here, we don't have straight line. We have curve. So this is non-linear. So the function is non-linear because the graph is not a straight line and doesn't have a constant rate of change. Identify linear and nonlinear functions from graphs. A square has a side length of s inches. The area of the square is a function of the side length. Graph the function to determine if it is linear or non-linear. Explain. The first step, make a table of values. Do you have any question?
Yes, Mr.
Yes, tell me, please.
And in example number 2, we need to see if it's linear or non-linear. How do we know if it's linear?
In this example or the previous example?
No, this example.
This example. Yes, I will explain. Just wait.
Okay.
Here we have square. As you know, square quadrilateral means have 4 equal sides here in the square. This side equal this side equal this side equal this side, and the length of each side will be s. And as you remember, the area of the square will be the square of the length, s squared. So here we have function. We want to determine if this function linear or non-linear. So at the first step, we want to make a table of values. So complete the table to show the area of the square for side lengths of. Here we have some values. We have 1, 2, 3, 4, and 5 inches. This is this values for the length of the sides. So the formula of the area of a square is
السلام عليكم أستاذ محمد عمر.
A equal S squared. عليكم السلام ورحمة الله. A equal S squared. So the first step, create the table. We have the first row here, side length using inch. The second row here we have the area using inch squared. And if you have the first value 1, so the side will be 1. Substitute in the function rule. Put the S1, 1 squared 1. Means we have the first point here 1, 1. If the second point 2, so put here the value of S2, 2 squared means 2 times 2 equal 4. So the second point will be 2, 4. If the value of the side will be 3, represent here S3 squared means 3 times 3 will be 9. So the point will be 3, 9.
Mister, we get the area by multiplying the side lengths.
Yes, as you remember, if you want to solve the area of the square, you can use the side times the side, or the side squared, or the side squared.
Thank you.
Okay. So if the value 4, put here 4 squared means 4 times 4 will be 16. So will be here 4, 16. If the value of S5, so 5 squared means 5 times 5 equal 25. So the point will be 5, 25. And if you have constant slope, or the rate of change will be constant, means you have linear. If you have the rate of change not constant, or the slope not constant, means you have nonlinear. And as you see here, 1, 2, 3, 4, 5, we have constant change here, plus 1, plus 1, plus 1, plus 1, plus 1. And as you see here, we have 1, then here we have 4, then here you have 9, then as you see here you have 16, then here you have 25. So as you see, from 1 to 4, we have plus 3. From 4 to 9, we have plus 5. From 9 to 16, we have plus 7.
So it's not linear.
From 16 to 25, plus 9. طيب. The graph the function. So graph the values in the table as order pairs, where x is the side length and y is the area. Then connect the points with a smooth curve. And as you see here, x-axis means the side length, and y-axis the area. So you can coordinate the points here. As you see the match between them, you will get what? Curve, not linear. And from the table, as you see here, we don't have constant rate. So from the table, we can know if linear or not linear, and we can know from the graph. As you see here, we have curve. This is
Mr.
not.
What's constant rate?
Repeat, please.
Mr. What is the rate constant or constant rate?
The constant rate means you have the same number. You can add the same number between the values here. Here, as you see, 1, 1, 1, 1. So this is constant. But in the second row, as you see here, we have plus 3, plus 5, plus 7, plus 9. Means you have a change in the values. When you have change in the values, means you don't have constant rate. So for example here, the rate 1 over 1. The slope here 1 over 1. The slope here 4 over 2. The slope here 9 over 3. So as you see, the slope here equal 1, the slope here equal 2, the slope here equal 3. So we have a change in the unit rate. We have a change in the slope. So it means this is not constant. This is not constant. So if you have the rate of change not constant, means you have non-linear. You have non-linear. So do the points lie on a straight line? No, this is not straight line. So the graph is non-linear. Is it okay for all?
Yes.
Yes, thank you, Master.
Great. In this example, a cube has a side length of s meters. The volume of the cube is represented by the expression s cubed. The volume of a cube is a function of the side length. Does the situation represent a linear or non-linear function? Explain. As you see here, just we have a graph. Just we have a graph. From the graph, as you see, we have here curve. This is not straight line. This is not straight line. So the situation represents a nonlinear function. If you graph the function, the order pairs, side, length, volume don't lie on a straight line. The second idea in this lesson, identify linear or nonlinear functions from a tables. You can determine whether a function represented in a table is linear or nonlinear. To do so, find the rates of change. Find the rate of change. If the rate of change is constant, the relationship is linear. If the rate of change not constant or isn't constant, the relationship is non-linear. So as you see here in the first table, study the numbers here in the x. In the x. X here means the input or the domain. So here we have 5, 10, 15, 20, so plus 5, plus 5, plus 5. And here in the y-axis or the range or the output, we have 8, 6, 4, 2, means negative 2, negative 2, negative 2, or subtract 2, subtract 2, 8 minus 2, 6, 6 minus 2, 4, 4 minus 2, 2. So as you see here, if you want to find the slope, here 8 over 5, 6 over 10, 4 over 15, 2 over 20. So the rate of change is always negative 2 over 5. Always negative 2 over 5. So the function will be what? Linear, because we have here constant rate, or we have constant slope. In the second case, here we have 1, 2, 3, 4 means plus 1, plus 1, plus 1. Here we have 1, 4, 9, 16. 1 plus 3, 4, 4 plus 5, 9, 9 plus 7, 16. So as you see here, we have a change in the values. So it means we have here in the first, we have the slope 1 over 1 means 1. Here the slope 4 over 2 equal 2. Here 9 over 3 equal 3. 16 over 4 equal 4. So we have a change in the slope. We have a change in the slope. So the rate of change here, 3 over 1, 5 over 1, 7 over 1, are not the same, So the function is non-linear. The function is non-linear. Identify linear and nonlinear functions from tables. The table shows the minimum number of daily calories a tiger cub should eat based on its age in weeks. In the first week here, we have 825 calories. The second week, the third week, the fourth week, etc. And as you see here, from 1 to 2, from 2 to 3, from 3 to 4, from 4 to 5, we have plus 1. In the second column here, 825. If you add 100 75, you will get 1000. Then if you add 185, you will get 1185. So as you see, we have change here in the value. So this is not constant. This is not constant. So determine whether the function is linear or non-linear. Explain. From week 1 to week 2, the rate of change is 175. And from week 2 to week 3, the rate of change will be 185. So the rate of change are not the same. So the function is non-linear. The function is non-linear. In this example, determine whether the table represents a linear or non-linear function. Explain. Here we have the first column, time, represent x, and here distance represent y. And here we have 3, 4, 5, 6, means you can know here the constant +1, +1, +1, +1. But here, from 9 to 16, you can add 7. From 16 to 25, you can add 9. From 25 to 36, you can add 11. So as you see, if you want to find the slope here, 9 over 3. 9 over 3 equals 3. And the slope here, 16 over 4 equal 4. And the slope here, 25 over 5 equal 5, etc. As you see here, this answer different than this answer, different than this answer. So means we have change in the slope, or we have change in the rate of change. So this is not constant. This is not constant. Means we have none.
Mr.
Yes.
Mr. If this this table was 3, 9, and 4 equals 12, and 5 equals 15, and 6 equals 6 times 3, 18, it will be linear or not? Like I register each number 3 and 4 and 5 and 6, we times it by 3, it will be linear?
Repeat please the values here. Here what you have here?
Here 9.
9. And here?
12.
And here?
15.
And here?
18.
Okay. طيب هلا find the slope here. The slope y over x, or rise over run. The slope here 9 over 3 equal 3. The slope here 12 over 4 equal 3. The slope here 15 over 5 equal 3. And the slope here 18 over 6 also 3. So as you see here, you have the same value for the slope. Means you have constant rate of change. So means in this case will be linear. Will be linear. But in the first case, as you see, we have different values for the slope. Means you have not constant change of rate. So the table represents a nonlinear function because the rate of change is not constant. Is it okay for all?
Yeah, Mr. Thank you.
Welcome.
Yes, Mr. Clear.
Now we want to learn identify linear and nonlinear functions from equations. Here we don't have a graph or table. We want to know from the equation. In order for an equation to represent a linear function, the equation must be able to be written in the form y equal mx plus b, where m represents the slope or constant rate of change, and V represents the y-intercept or initial value. So if an equation represents a nonlinear function, it will have one or more of the following characteristics. So when you have powers other than 1 on the variable, when you have square or cube roots of variable expressions, when you have variables in the denominators, or a fraction. So as you see in this equation, you have here squared. When you have the degree of the variable squared, means not linear, not linear. So as you see the graph here, we have curve. As you see here, we have the degree 3. So this is a cube. So when you have the degree of the variable up 1, means non-linear, non-linear. So as you see the graph here, non-linear. If you have square root or cube root, so means non-linear. So as you see here, non-linear. If you have a fraction and the denominator will be variable. If you have a fraction and then the denominator will be variable, so means non-linear. Non-linear, as you see this graph, non-linear. Identify linear and non-linear functions from equations. Determine whether the equation represents a linear or non-linear function. Explain. As you see here, we have y equal x over 3. Here we have fraction, but the denominator will be constant, not variable. The denominator here will be constant, not variable. So the equation y equal x over 3 can also be written as y equal 1 over 3x. 1 over 3x, like y equal mx. This form, like this form. In the equation y equal 1 over 3x, in the form y equal mx plus b. Yes, but the value of b here will be what? 0. So the equation y equal x over 3 represents a linear function because it can be written in the form y equal mx plus b, where m equal 1 over 3 and b equal what? Equal 0. In this example, determine whether the equation represents a linear or nonlinear function. Explain. We have this equation. Is it this equation like this form y equal mx plus b? Now this equation can be written y equal negative 2 over 5, negative 2 over 5 x plus 5. So this form, like this form, as you see the slope here, m equal negative 2 over 5, and the y-intercept b equal 5. So means this is linear. This is linear. So the equation represents a linear function here because the equation can be written in the form y equal mx plus b. Identify linear and nonlinear functions from equations. Determine whether the equation represents a linear or nonlinear function. Explain. As you see in this equation, we have here squared. If the degree of the variable up 1 means nonlinear, So the equation y equal 3x squared plus 2x plus 5 cannot be written in the form y equal mx plus b, because the variable x is raised to a power other than 1. So the equation y equal 3x squared plus 2x plus 5 is nonlinear because it cannot be written in the form y equal mx plus b. Determine whether the equation represents a linear or nonlinear function. Explain. As you see in this equation, we have square root. So means not linear because we have square root, because we cannot because this equation cannot be written as y equal mx plus b. So the equation represents a nonlinear function because it cannot be written in the form y equal mx plus b.
Mister, can you explain again why it can't be wrote in y mx plus b?
In this example,
Yes, the example.
can you write this form like y equal mx plus b? We cannot write this form like this form. Why? Because here we have square root. Here we have square root. So means this is non-linear because we cannot write this equation as y equal mx plus b. Okay, Muhammad?
If any equation has root, we can't write it in y mx plus b.
Yes. Root.
Okay.
As you see here, we have the first one. If you have powers, if you have square or cube roots, and if you have variables in the denominator. In the numerator, no problem. But if you have variables in the denominator, means non-linear. So here we have three cases when you have in the equation powers or square or cube roots or fraction and the denominator will be variable, so means the equation not linear. The circumference of the circle. The circumference means the length of the frame of the circle. This line, the total of this line, this is the circumference of the circle. As you remember, the circumference represents C equal to by R. As you remember, R means the radius. The radius means the distance from the center of the circle to any point in the circumference of the circle. This distance, radius. This distance, the radius. So here is a function of the circle's radius. Similarly, and the area of the circle is also a function. And as you remember, the area of the circle A equal by R squared. Which of this relationship is a linear function? Construct an arrangement to justify your response. When you can write any equation in this form, y equal mx plus b, means this is linear. So the first function, c under y, 2 by under m, r under x, and the value of b here will be 0. So this form like this form, so means here linear, here linear. But in the second equation we have squared, and when you have squared in the equation means not linear, means not linear. So the relationship between the radius and the circumference of a circle is a linear. The relationship between the radius and area of a circle is nonlinear. The area of a square is a function of, it is a perimeter. And as you remember, the perimeter of the square equal 4s. S the side of the square. And the area equal s squared. So this form like y equal mx plus b. As you see here, m 4 and x s. And the value of b here will be 0. But here in this equation we have squared. So here we cannot write this equation as y equal mx plus b. So the first function means linear. The second function not linear. So the relationship between the perimeter and area of a square is a nonlinear function. The relationship between side length and perimeter of a square is a linear function. So this is our lesson for today. Who has any question about these ideas?
No question.
No, Mr. We understand. It's easy.
Thank you, Mr.
Great.
Mr. Do we leave or what?
Yes, if you don't have any question, you can leave.
Goodbye, Mr.
Bye.
Bye.
Goodbye, Ustad.
Thank you, Mr.
Thank you, Mr.
مع السلامة أستاذ.
مع السلامة.
يلا شكرا أستاذ.
حياك الله. So this is our period for today. Thank you for your listening. Have a nice day. See you tomorrow, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.